is a video, we will understand the concept of a supermesh in electrical circuit. So, before we understand the concept of a supermesh, let us understand the mesh analysis method. The electrical circuit as it will help us in understand the concept of a supermesh. So, we will using one example. Let us say we have one given electrical circuit.
Question and answer. Given circuit, you need to find the value of I1, I2 and I3. Follow this step. First, evaluate if the circuit is a planar circuit. Label each of mesh current in the circuit, like this, I1, I2 and I3. Form a supermesh if the circuit contains current source by two meshes. As you can see here, this is between two meshes. So, you need to eliminate this for one and it will become like this. So, step 4. Using KCL method. So, first you need to make new meshes, still I1 and I2. After you label the meshes, by using step 4, by using KVL and supermesh, follow the mesh and it will become negative. Negative is 1 plus 4 I2 8 I3 equal to 0. This is equation 1. Then KVL at mesh I3 is 1. As you can see by using the loop, this will become I3 equal to 0. Then 4I2 I3. This is equation 2. After you done the step 4, using KVL, this one, at supermesh and KVL at mesh I3, then proceed with using KCL and you need to redraw the circuit. Like this one. Draw back this one. KCL is Kirchhoff current law. So current in at node 0, this I1 out and this I2. So the equation will be like this. I2, I1, 3 ampere. In, out. So in, it will become I2 plus 3 ampere. Out, I1. This one, it will become I2. This I2. 3. So this is equation 3. For the step 6 substitute equation, by using the Cramer's rule, we have equation 1, equation 2 and equation 3. As you can. This one. 2, 12, negative 6, 2, 4, negative 8, 1, negative 1, 0. I1, I2, I3. So this one. By using the calculator, you will get the answer using the equation. So I1 is 4052 ampere, I2 1052 ampere, 13. So this is the answer for I1, I2, I3 by using supermesh. Thank you.
Supermesh. Supermesh technique is quite handy in the cases where you find a current source that is connected between two meshes. So, in such cases, instead of writing at two separate KVL equations, we consider these two meshes single entity and write only a single KVL equation at a supermesh.
Okay, for this part of video, I would like to explain about the equation of the supermesh by using this diagram. So as we can see here, to identify the circuit whether mesh or supermesh, if the circuit they already give the current flow here, it become a supermesh. The supermesh is which the parallel circuit become one series circuit. So if one series circuit, the R will be removed because the current flow here is the same, which is 6 ampere. So the first formula of the supermesh equation is negative I1 plus I2 equals to 6. Why negative I1? Because in I1 and I2 both are sharing the 6 ampere. So the negative because here the current flow is moving opposite of this current, so it become negative. Plus I2 equals to 6. So the second equation is, which is, as we say, become one series circuit, right? So firstly, the current flow here, so is going through negative, so then the volt become negative 20 plus 6 I1, since the resistor 1 is sharing the I2, plus 10 I2 plus 4 I2 equals to 0. So the as we see here, by subtracting it, we become 6 I1 plus 14 I2 equals to 20, since we bring this voltage over here. So after, by finding this two equation, we just substitute the 1 over here, 1, which is the firstly, we have to make it 1 as a equal. So I make it I2 as equal 6 plus I1. So after that, we can substitute the I1, substitute the first equation into second equation, which is 6 I1 plus, since the I2 become 6 plus I1, so I1 plus 6 equals to 20. So secondly, by what do we say that, just times by here, bring the 84 over here, become negative 64, and then bring the 20 over here. So the I1 is equals to negative 3.2 ampere. So after finding the I1, we can easily find the I2, which is by using the first equation. So I2 is become negative 3.2. So here is negative, right? So negative, negative, positive. So after the positive, we must to find the I2. So bring the 3.2 over here. So become I2 equals to 6 minus 3.2. So which is I2 equals to 2.8 ampere.